Excuse me 1 minute. Okay. I'm sorry for the minor disruption. Cost us a few minutes, but I think we get through what we need to do. Okay, so we have P equals 2L plus 2W. Our goal is to isolate L. That means we don't want the 2 here and we don't want the 2W here, right? So what can we get rid of by addition or subtraction? First question, what do we get rid of by addition or subtraction? Okay. We don't think about multiplication or division until we've taken care of addition and subtraction. And what we can do is, and we can write this down, way people like to, negative 2W here and negative 2W here. We line it up with the W so we don't try to subtract the W from L or something like that. And you add these two equations and we get P minus 2W. Let me move over a little more so I don't block the camera. Equals 2L because 2W minus 2W is just 0, right? So we've subtracted the 2W from both sides, and now we've got something where addition and subtraction is not going to work. Okay? Because 2 is multiplied by L. You can't get rid of the multiplication by subtracting something. Okay? So we need to divide both sides by 2. Get rid of that 2. So we do P minus 2W over 2 equals 2L over 2. And then the 2 here divides the 2, and we get L, and we get P minus 2W over 2. And then we probably write that with the thing we're trying to solve for on the left, because that's kind of where we expect to find it. So we just switch sides, which doesn't change the fact that these two things are equal, so it's legitimate. And we get this. Okay, now, what good might that do us? Well, okay, formula for the perimeter of a parallelogram. Now I'll just kind of continue this on the flow. Actually, if we use L and W, we're probably talking about a rectangle. Now, the formula for a parallelogram is the same, except we'll probably use B and H for base. Or sorry, well, what do we use for parallelogram? For the area, we use base and L. We might use 2L and 2W, but the problem in the parallelogram is that W is the width. If things at an angle, you don't call it a width. So let's not be confused by that. Let's just say, okay, this is perimeter of a rectangle. It'll also work for parallelograms, as long as you don't call that a width. Okay. Well, L is the length. Okay. L equals P minus 2W over 2. And this formula gives us the length if we happen to know the perimeter and the width. So we got a bunch of rectangles. We could take that formula very quickly, calculate all the lengths. That's an unlikely scenario. We probably wouldn't be in that situation, but if we were, we could do that. What you have to understand is these formulas can be rearranged to give us one variable in terms of the others. Okay, we could have solved for the width in terms of the length, it would have been very similar. Okay, well, for the width in terms of the length of the perimeter. So we have subtracted 2L from both sides and so forth. We've gotten a very similar formula. Okay. Okay, well, let's move on to the next one. Okay, now, so a couple of you, I think, at least in some cases, on some problems, substituted 3.14 for pi. Don't do that. Unless you know it's okay. Leave it as pi. First place, it's easier to deal with in the equation, and you can approximate it by 3.14 later. But sometimes you're in a position where you need much more precision. You might need 3.1416 or 3.141592. 6. I think that's a 6. Okay, and after that, I don't know. All right. And if you use 3.14, you're going to get a different result than you would if you used a different approximation. Now, what you would do with your calculator is there's a pi button on the calculator. Okay. So you use the pi button. And then you get a very accurate, still an approximation. It's not totally accurate. But you know, you'd be calculating a radius down to the width of a proton. Okay, or something like that. So accurately that almost no conceivable measurement, at least no measurement that anybody but a research physicist would use. Okay, or a research mathematician. Wouldn't make any difference. Okay, wouldn't make any difference to any engineer in the world, unless they also happen to be a research physicist or astrophysicist or whatever. Okay, well, anyhow, there we have it. A equals pi r squared. How we're going to solve for r. Okay, well, I'm going to write down a couple of questions. And are there additions or subtractions involved? No, there's only multiplications, right? I'm going to say, we don't add or subtract anything. And there's our first question. And if you're not getting all these and not doing real well with them, write that down. Okay, now you could just say adds, subtracts, question mark, no. To abbreviate all my words, I recommend that you write out all my words. First half dozen times you do it, just to get it locked in and to get the logic locked in. Okay, so we don't add or subtract like we did over here because there was an addition involved. Okay. If there's an addition involved, then you got to consider adding or subtracting. All right. Now, again, we're trying to solve for r. So it's r that we're looking at. Is r multiplied or divided by something? Okay. It's actually r squared. is multiplied by pi. So we divide both sides by pi. So now we got a equals pi r squared. Which tells us then that a over pi would be pi r squared over pi. So that a over pi equals r squared. Okay, now we have a power of r. Is there an exponent involved, right? We have an exponent in the variable r, yes. The exponent is 2, so r is squared. Now, if you have an exponent other than 2, I don't necessarily expect you at this stage, where we haven't studied exponents, to know what to do, okay? But if it's squared, I do expect you to know what to do, okay? Take the square root of both sides. Remember that you're going to have a plus or minus. Okay? You always have a plus or minus when you take the square root of both sides. So we have r squared equals a over pi. So r equals plus or minus the square root of a over pi. Okay? Now, it turns out that now that you have the plus or minus, you say, but r is a distance that's never negative. So we can discard the negative. Okay? So we discard the minus to get r equals square root of a over pi. Always, when you have something squared equals something else, that something will be plus or minus the square root of something else. Sometimes the plus and the minus are both valid. Okay? But since the thing you're getting is a quantity that can't be negative, you discard it. But always write out this step and then say, okay, we can discard the minus in this case. Always consider whether you discard the minus or not. Okay, well, no, I got a question. Okay, so the question is, why is it plus or minus? Doesn't want to move. Okay, consider. Let's apply plus and minus. Consider x squared equals 9. Okay. X equals 3 is a solution, right? If you square 3, you get 9. Okay. What happens if you square negative 3? You get 9. Negative 3 times negative 3 is positive 9. Two negatives give you a positive. product of two negatives is a positive, or the quotient of two negatives. Okay. So solution x equals plus or minus 3. Depending on what x represents, both of these might be valid. In this case, we solved for r and got a plus or minus, but we know that r is a distance and distances aren't negative. Okay, so we know now, having solved this, well, r being a negative doesn't make any sense, so we can discard the negative and we can write this as a solution. Okay, but in general, an equation x squared equals 9 have two solutions, one positive, one negative. We always want to write out the positive and the negative. Okay, and that's going to come up later. See what? Remember the quadratic formula? Anybody remember the quadratic formula? It involved an expression like negative b plus or minus the square root of b squared minus 4ac, all that divided by 2a. Okay, you maybe have seen this, maybe you haven't. But you're going to. And it's an easy formula to use. You just got to keep your wits about you and know when it applies. And we'll stress that. Spend a whole day on that. Okay? Make sense? So, you know, this plus or minus comes about for the same reason this one does, but it's in a little more involved. Not that involved. You'll understand it. But a little more involved situation. Okay? And some we're not ready to talk about yet. Okay. And then, well, I just, over Jack. Okay, the last equation. Okay. And we want to solve this for h. Now, if we wanted to solve this for b, that would be a quadratic equation because b is squared here. And it's not squared here. And we would probably end up using that formula I just put on the other side of the board. Okay, so there's a situation where it just comes up pretty naturally. We don't worry about it right now. When we get to it, you find you don't have to worry about it if you just pay good attention to it, okay? It's not that difficult. Okay, so here we have it. So I didn't ask you to solve for b. That would have been something you're not equipped to do yet. I asked you to solve for h. So never do a multiplication when you're doing addition or subtraction. Never do multiplication or division if an addition or subtraction will get you toward your goal when you're solving formula. So we're trying to solve for h. We'll remind ourselves we'll just circle that h. So we're trying to reduce everything on this side down to just h. Okay? And some people will want to divide bh by b. Okay? In order to get h by itself. And actually, in this case, that would work, but it's a very bad idea because often it doesn't. Okay? And often it leads you to a more complicated expression. So add or subtract. Yes. What do we subtract? We subtract pi b squared over 2. So we subtract the equation, and we get a minus pi b squared over 2 equals bh. And now it's pretty easy to solve for h. We just do this in 2 steps and we got it. Now this side needs to be simplified a little bit, and that can be a stumbling block. But as far as just getting a formula for b that'll work, I'm sorry, for h, formula for h doesn't work. Let me circle h and know what I'm solving for. Okay. I'll say add or subtract. I say no. I'll say BH is isolated now. Okay, it's there all by itself. There's nothing added or subtracted, but we do have a B in front of it. We multiply or divide, or do we have a multiplication or division? Yes. A is multiplied by B, so it should be so this thing here is divided by B. That's equal to BH over B. So H will equal what's over here since the B was divided by B. H equals A minus pi B squared over 2, all divided by B. So there's a step of simplification that we want to try to understand. Let me write this once more. Okay. Well, when you divide an expression by B, it's the same as multiplying by 1 over B. Okay, dividing by B is the same as multiplying by 1 over B. So we have 1 over B multiplied by A minus pi B squared over 2. Okay, I'll say division. By B is the same as multiplication by 1 over B. Okay. So that then H equals 1 over B times A minus 1 over B times pi B squared over 2. Because 1 over B is multiplied by everything in here, meaning 1 over B is multiplied by A and it's multiplied by negative pi B squared over 2. Okay, it's a distributive law. One over B times A is just A over B. It's like 1 times A over B times 1. And then I'll say this is equal to pi B squared over 2B. By the B by the 2, the 1 by the pi B squared. There's your product. B squared is like B times B. We're dividing by 2B. So this B will divide one of these B's. We'll divide them both. Okay. So after we get our solution, there's actually more work in simplifying this, and you need to know more algebra to simplify it than you do just to solve it. Okay. But ponder this, because in general, you do need to simplify these things. Okay. I wouldn't be too likely to give you one that has that complicated of a simplification at this stage of the course. But slightly less complicated, yeah. Okay, on the level of what you see in your homework. Okay. So. Okay, we're going to move on and talk about inequalities, I think. Okay. Linear inequalities. Let's just say we have 2x plus 4 greater than 8. Okay. We can add or subtract the same quantity on both sides of an inequality, just as we would with an equality. Just like we would if it was an equal sign here. We can subtract the equation -4 equals -4, which is going to give us 2x greater than 4. Adding an equality to an inequality doesn't change the fact that you still have that same inequality, okay? And then we can divide both sides of the inequality by 2, can't we? Well, this inequality is the same as this, okay? If you take any number greater than 2 and put it in here, it's going to give you a true inequality. So check that. Check. For 2 different values of x. Plug in x equals 1 up here and see if it's true. Then plug in x equals 3 and see if it's true. Okay, so do that on your paper. Plug in those numbers and see what the inequality gives you. Okay, so check for x equals 1 and 3. Why 1 and 3? 1 is a little bit less than 2, and 3 is a little bit bigger than 2, right? So just kind of convince ourselves, take a number that's a little less than 2, a number a little bigger than 2. Now, if x is equal to 1, then x greater than 2 is false, because 1 isn't greater than 2, right? And I could say, I'm going to say, clearly 1 greater than 2 would be false. 2 times 1 plus 4 greater than 8, which is our solution, or our original equation, our original inequality, tells us that 2 plus 4 is greater than 8, tells us that 6 is greater than 8. That's also false. So this is false, and this is false. Okay. So what I'm trying to tell you is that anything that makes this true, any value of x that makes this true, should make this one true. Any value of x that makes this one false, should make this one false. Okay, so now if x equals 3, then x greater than 2 is true. As 3 is certainly greater than 2. And what we get when we substitute here, 2 times 3 plus 4 greater than 8 gives us 6 plus 4 greater than 8, which gives us 10 greater than 8. also true. This is true. And this is true. Okay. And you can't find any number less than 2 that'll make this true. And you can't find any number bigger than 2 that'll make this false. Okay. If X is less than 2, this is always going to be true. If X is greater than 2, this is always going to be. I said that right. If X is less than 2, this is always false. Okay. If X is greater than 2, this is always true. Okay, now what we do is we can graph that solution. Here's an x-axis. And here is where X equals 2. Okay. Now can you draw this picture? And can you draw me about this? What's your quote? Bunch of X's on the line. And then circle the ones that are greater than 2. I want you to circle the points. I want you to draw, several points there and circle the ones that are greater than 2. Okay, we wanted to make sure that everybody understood a number line. Okay, this often people sign up for this course and don't. And we want to make sure we accommodate that. Okay, it's not hard to understand, but everybody's got it. A circle of points where X is greater than 2. Well, that would be these points, right? Now, if I want to indicate all the points where X is greater than 2, I do it like this. I draw an arrow here that indicates that the points where X is greater than 2 just keep on going forever. So that arrow indicates a line keeps on going forever. Does that make sense? And the other thing I do is I put a little circle. We used circles before, but this is going to be a real circle that we actually use. I put a circle around X equals 2 to indicate that X equals 2 is not included because X equals 2 is not greater than 2. 2 isn't greater than itself. It's equal to. Okay. Well, there you have it. That's how you graph the solution to an inequality. That makes sense? And the number corresponding to every point here on this arrow, other than the X equals 2 point, is a solution to this inequality. Makes this inequality, makes this left-hand side greater than 8, makes the inequality true. Okay. Now I'm going to demonstrate another inequality. Now I've gone through all the detail of checking whether it's true or false. I'm just going to assert this, and then you can see how that works out as you work through the open math assignment. And let's say I've got negative 3x plus 6 less than 15. Can you go ahead and solve that? Now, there's something that you might well not know that you're probably going to do wrong, but then we'll fix it. It's real easy to fix. Okay? So go ahead and solve this. Okay, now, some of you knew and some of you didn't. There's a little twist on this solution. Okay, now, some people are still working on their paper, so I'm going to give you a little extra time here. Okay, everybody did a very good job on this. There is one rule that not everybody remembered. Okay? And that's real important. So what we have is, we'll go ahead and subtract the equation -6 equals -6. Remember, we make this an equation. Okay? We need to get used to that. When you add an equation to an inequality, you still get the inequality. Adding something's equal to itself on both sides doesn't change the fact that this side is less than this. If this is less than this and we add the same number or subtract the same number on both sides, what we get will still be, on this side will still be less than what's on this side, right? So we get -3x is less than 9. There's always a temptation to make you put the equal sign here to write an equal. But no, think about what's going on. You're adding two things that are equal to two things that aren't. Those two things will still be unequal. Okay? Then we divide both sides by -3. And temptation is to write a less than there. So you knew. And it's just a question of whether you've seen this before. That when you multiply or divide by a negative, what's less becomes more. What's more becomes less. And the inequality reverses. Now, hopefully open math will make that even clearer to you. Whether it's clear why that's true or not, right now, make sure you know that it's true. This is the only difference between equalities and inequalities. Okay? With equalities, equality never changes when you do the same addition or subtraction on both sides, right? But with inequalities, it reverses. So you get x greater than -3. Now, if you got x less than -3, then you would think that -4 would make this true. If you plug -4 in here, you get 18 less than 15, which isn't true, which tips you off to the fact that you forgot to solve. I would just say check with x values -4 and -2. That'll tell you for sure if your inequality is going the wrong way. Okay. And then you could graph it the same way. You just have x equals -3 and shade everything to the right. Okay. So that's about it. I mean, there's a little more, but I don't want to lay any more than that on you right now. Because if you understand this, I think you'll understand everything else that you see in open math. And they might throw some off the wall problem at you that people have trouble with it. So we'll talk about it next time. But I think if you work conscientiously the way you have been, this will give you very little difficulty. Just keep in mind that one rule, multiplying or dividing by a negative changes the sign. There's another thing that's coming up in your assignment this weekend that often throws people off a little bit. And that is absolute value. Now I'll give you the intuitive idea of absolute values. It does get a little more subtle, what I'm saying, but the intuitive value the absolute value of 5 is 5. Absolute value of -8 is 8. So tell me what you think the absolute value of 12 would be. The absolute value of -18. The absolute value of 5 minus 4 minus 2. And the absolute value of 2 minus 5. Put those down. I don't know. And tell me what you think the absolute value would be. Okay, everybody seems to have gotten this just fine. The absolute value of 12 is 12. The absolute value of 18 is 18. And what we do is we just ignore the negative sign. Okay, when we know what the number is. Okay. Now the absolute value of 5 minus 2, there are 2 steps, and I didn't see everybody writing out the steps. First, we got to do 5 minus 2 because it's inside the absolute value signs. Just like inside of parentheses, you got to do what's there. So that gives us the absolute value of 3, and then we know that's going to be 3. 2 minus 5 is -3, but the absolute value of -3 is still 3. Okay. So there's the idea. Now there's a rule that you're going to read that I found confusing when I first saw it. Okay. And I first saw it after I'd learned to do a whole lot of stuff with absolute values. The definition is if the number is positive, then the absolute value equals that number. If the number is negative, the absolute value is the negative of that number. Okay. What's the negative of -8? Say. This is positive, so that's the absolute value. This one's negative, so you just take the negative of that and you get 18. Now, I just mentioned that. We'll see why that's important very shortly. Okay, so let's say we have the equation absolute value of x equals 14. How many different numbers could x be? Write down what you think all possible numbers x that would make this true. Okay, here's the solution. One solution is x equals 14, right? If you replace x with 14, you get 14 equals 14. And there's another solution. Let's see what that would be. -14, the absolute value -14 would be 14, right? Because there are 2 solutions. So we could write that out formally like this. Absolute value of x equals 14 gives us 2 equations. X equals 14. Somehow my hand just doesn't want to write a good form there. I'm off to such a good start. This is the way I want you to write that out. And I'll explain why. For example, let's say we have the equation x plus 5 equals 14. Okay. This breaks into 2 equations. What has to go inside the absolute value sign? It has to be 14, right? Got anything besides 14 in here, or -14, I'm sorry, 2 possible values. If you got 14 in here, it's true. If you got -14 in here, it's true. Well, you say then that x plus 5 is 14, or x plus 5 equals negative 14. That makes sense? If you got the absolute value of something equals 14, then that something had better either be 14 or negative 14. That's the one thing you got to learn. And only 50% of a given class will do that, despite my saying that as clearly as I just did, maybe even more clearly, maybe 4 or 5 times, and open math showing it. People will just remove the absolute value signs and solve this equation. Please don't do that. Okay? This equation breaks into 2 equations, which are now easy to solve. So we can add -5 to both sides and get x equals 9. Or we could add -5 to both sides. In other words, add the equation -5 equals -5 and get x equals -19. Then we can check. Plug 9 into this equation. Absolute value of 9 plus 5 equals 14. Absolute value of 14 equals 14. That's true. Checking this solution. Absolute value of -19 plus 5 equals 14. You get absolute value of -14 equals 14. And that's also true. Okay. That's everything you need to know about solving absolute value equations. Now, what's inside here might be really complicated. Okay. But we're out of time. Not want to complicate your life. That won't be assigned until this weekend. We'll talk about it more next time. Make sure we really understand it. Okay. Because there are many, many equations that break into 2 equations or more. We want to get this probably the simplest case here, because you don't have to do much. Just have to take this thing and set it equal to 14, and whatever's in here set it equal to -14, and then solve what you got. Okay. There are more complicated cases where you split into 3, 4, 5, 58, 3,962 equations. You wouldn't have to solve that many. Okay. So here we have it.